Hello dear students, welcome to this introductory session for engineering mathematics. In this session, I am going to discuss the syllabus of engineering mathematics in GATE examination by comparing the syllabus in various branches. Before starting the discussion, this is about me, myself Sridhar Dhulipala. I am having 20 plus years of teaching experience. My qualifications are M.Tech Saka from NIT Karnataka Surathkal and MSc Mathematics from JNTU Hyderabad. I teach engineering mathematics for all the branches, whereas for computer science student exclusively I teach discrete mathematics, algorithms, programming and data structures. You can join my Telegram group EM by Sridhar Sir to get regular update about my classes in various channels. You can also join my Facebook as well as Instagram pages here. First, let us see the topics. First, I will give you all the topics, then we will discuss each of these topics in detail by comparing syllabus in various branches. We have linear algebra, and before starting calculus, we should know some prerequisites like trigonometry and functions. Calculus can be discussed in two parts, function of single variable and function of two or more variables. Probability also can be discussed in two parts. Under probability 1, we talk about basic probability, addition theorem, conditional probability, Bayes theorem, etc. Whereas under probability 2, we talk about random variables, probability distributions, both discrete as well as continuous probability distributions. Under differential equation, we talk about first order and higher order differential equations. See, multiple integrals are generally discussed as part of calculus, but I generally discuss as a separate topic because it forms basis or prerequisite for vector calculus. Under vector calculus, we discuss vector differentiation as well as vector integration. Same is the case for complex analysis, complex differentiation and complex integration, but complex analysis is not in the syllabus for civil engineering students GATE syllabus. But this is one of the important topic for ESE examination. So, if you are aiming for ESE, you cannot skip this topic. Numerical methods. See, the purpose of dividing into two parts is because the second part it is not in the syllabus for many branches. Even nowadays, even first part is not in syllabus for many branches, my dear friends. Okay. Then we have Laplace transforms, Fourier series, partial differential equations. See, this Fourier series and partial differential equations go together. For example, for civil engineering students, partial differential equations is mentioned in syllabus as a separate chapter. Okay, so it is very important for them. So, if you want to discuss partial differential equation, we need to know about Fourier series, especially the half range Fourier series. Okay, so these are the topics, my dear friends. Now, let us discuss the topics in detail. Let us start with linear algebra. So, in linear algebra, we are having the following subtopics like matrix algebra. We should understand the basic structure of matrices. See, mainly we talk about matrices. Linear algebra is study of linear equation, but the important tool for studying this linear equations is matrix. So, that is why we need to discuss about matrices more before actually we start with linear algebra. So, you can say like 60% of the syllabus we talk about matrix algebra or matrix theory, the tool, then the remaining part is linear equations, the study of linear equations. Okay. So, that is why we study matrices more under linear algebra. Okay. So, we have matrix algebra, special square matrices and their properties, and two important tools for various topics are like determinant and rank. Finding determinant, finding rank, and the properties of determinant and properties of rank plays very important role for future topics. If you want to solve system of linear equation, definitely we should know about rank of the matrix. So, rank can decide the type of the solution for system of equations. Let it be non-homogeneous, yeah, homogeneous system. And when it is a homogeneous linear system with square matrix A, then determinant can decide the type of the solution, my dear friends. So, both determinant and rank plays very important role in study of system of linear equations. Then we have eigenvalues and eigenvectors, one of the important topic for GATE point of view. You can get number of marks from this particular topic, my dear friends. Diagonalization is one of the part. Okay. Very rarely we can get questions from this, but it is very interesting and important topic. If at all you get question, it may be worth of 2 marks. So, you can't skip it. Then we have this LU decomposition. See, generally LU decomposition is discussed as part of numerical methods, but nowadays linear algebra plays very important role in data science. The factorization methods like LU, QR, SVD, they play very important role. So, if you are interested in that, start with this LU decomposition, sir. Of course, not only that, for GATE point of view, even for ESE point of view, this is one of the important topic, and we learn very beautiful shortcut for finding this LU decomposition. And if you see or if you compare the syllabus of linear algebra in various branches, it is like this. See, actually if you observe, matrix algebra is mentioned in almost all the branches except for electronic and communication. You can find system of linear equations and eigenvalues, eigenvectors mentioned in almost all the branches. Okay. Of course, even here matrix algebra is mentioned, but in a different order. Okay. So, eigenvalues and eigenvectors is mentioned, linear system of linear equations is written like solution of linear equations. Okay. Everything is same. Am I clear? So, the syllabus is common. Only if you find this EC syllabus, there are some special concepts mentioned like vector spaces, basis, linear independence and linear dependence. See, if you do not understand this, how can you find eigenvectors, sir? See, obviously if you are learning how to find eigenvectors, you need to discuss all these concepts. So, internally they will be definitely discussed. We will try to discuss in little more detail, so that you will understand this clearly for EC branches, whereas for other branches internally the details required also can be known. Okay. So, that is about the syllabus for linear algebra. And these are the prerequisites before starting with your calculus. We should know some basic properties. Generally, I give you a sheet around which contains around 8 basic results. If you know, that is good for health. Even functions. See, many people do not even know the graphs of basic functions like sine function, cos function, e power x function, logarithmic, some basic graphs, some basic properties of the functions. Okay, well known functions you should know. That is the purpose of knowing about functions, prerequisite, as a prerequisite, because function is a prerequisite, basic for calculus. Now, under calculus 1, we discuss about function of single variables and their properties. See, the calculus is an important tool which help us in knowing more about the function. Okay. So, the calculus operations help us in analyzing the functions. Okay. So, we need to know about limit, continuity and differentiability. And this very interesting topic called indeterminate forms. You can find number of questions from this indeterminate forms which were asked in GATE examination. You can say around 40 plus problems you can find which were asked in GATE examination in this particular indeterminate forms. Even ESE examination also, it is very important. Then we have the mean value theorems Taylor series. And one more very interesting topic and important topic is maxima minima for function of single variable. So, here the procedure based and common sense based questions they generally ask under this maxima minima, my dear friends. Okay. We need to understand that particular procedure. If your function follows that particular procedure, then you can decide the maxima minima. Here we generally call them as local maxima and local minima, my dear friends. Of course, we also discuss the absolute maxima and absolute minima for functions which are defined in a closed interval. Okay. That also will be discussed under this maxima minima topic, my dear friends. Then we have this integration. Of course, they generally mention definite integrals. It is better to know the basic integration techniques and basic integration formula before starting with definite integrals. Definite integrals also we need to discuss the main properties and how to apply these properties to solve the problems. Under application of integration, we will try to learn how to find area under the curve, arc length, okay, surface areas, how to find surface areas and volumes of solid of revolutions, all these topics we are going to discuss. See, we can find a good number of questions from this application of integration, and whenever they ask, this is generally for 2 marks. So, do not ignore this. Okay, even there are some special improper integrals also need to be discussed, like gamma function, beta function, which are very, very helpful for gate point of view. Then we have calculus 2, where we mainly talk about the properties of functions of 2 or more variables, because function is having 2 or more variables, we cannot have ordinary derivative, we find partial derivatives with both the variables. Okay. So, we discuss partial derivatives, and maxima minima for function of 2 or more variables will be discussed under this. There are also some special topics like total derivative chain rule will be discussed under this calculus 2, my dear friends. There is one more very interesting topic called homogeneous function, and the properties of that particular homogeneous function is very, very interesting. Then under multiple integrals, we will learn how to find double integrals and triple integrals with constant limits of integration and variable limits of integration. Then how to change the order of integration, how to change the variables, and there is one very, very interesting formula called Dirichlet integral method, or formula you can call it, which can solve some problems just like that. Just using the formula, you can solve many problems very, very quickly, especially that volume based problems. And when you compare the syllabus of calculus for various branches, you can quickly see this function of single variables that is mentioned, function of single variable, it is not mentioned for ECE, but that is what we are going to discuss. Okay. Then here also for electrical and CS also they are not mentioned, but that is it. Okay. Then we have this limit, continuity and differentiability explicitly mentioned for civil and mechanical. It is not mentioned for ECE electrical, my dear friends. That is mentioned for CS student. For CS students, you can see it is mentioned explicitly. Okay. Then we can see the local maxima minima, some people are saying, or maxima minima. Maxima minima is definitely mentioned in the syllabus. Maxima minima is generally mentioned in the syllabus. I think here it is mentioned separately by combining for both first, I mean maxima minima for function of single variables as well as 2 variables. Here also it is mentioned. It is definitely mentioned, sir. It is one of the important topic. Then we have this definite integrals and application of definite integrals to find areas and volumes they are mentioning. Partial derivatives is mentioned, total derivatives is mentioned. Here also they mentioned partial and total derivatives. Of course, for mechanical you can see this improper integrals is mentioned. See, it is like the syllabus is given in an abstract manner, it is not a detailed syllabus. So, you cannot take like blueprint and go for the examination, sir. That is the difference between your university examination and GATE examination. In university examination, they clearly mention what are the subtopics also. Here generally the abstract syllabus will be given to you based on your previous papers, okay, based on the experience of the faculty, you know what topic to be discussed or studied for this particular examination. So, that is where exactly we step in. Okay. So, please follow our classes regularly, you will understand what topics to discuss more, okay, to practice more, and what topics to study at least to so that you can answer the questions when they ask in examination. So, we clearly mention all that when we discuss in the classes. Okay. So, that is about it. And here if you observe there is something called Fourier series. In some branches it is discussed together or it is given in calculus syllabus, whereas in some branches it may be given in separate part. Even you see multiple integrals is given together with calculus part only. See, actually if you observe for CS student, multiple integrals is not mentioned in the syllabus, but last year you can find a question from multiple integrals. Of course, it is a very, very simple straightforward question, but the problem is people are unable to adapt to the situation and answer such easy questions also. So, it is better to know some additional topics so that you are fully ready for the examination, especially when you are going for competitive examination. Then we have probability. See, for probability we need to start with the basic probability. Generally this basic probability they discuss under aptitude more, but I generally in my classes I also start with the very, very basic probability, the probability axioms. I will tell what is sample space, what is event, okay, every concept, what is random experiment, every concept I will tell you from the basics, so that this help us in understanding the higher concepts very easily. Okay. Then conditional probability is very important, it is mentioned in the syllabus. Then the Bayes theorem, total probability theorem and Bayes theorem go together, these two play very important role, my dear friends, they are very important. Of course, there is something called statistics also they mentioned. See, the basic idea is whenever you have data or distribution, we need to talk about the properties, okay, and the properties are obtained by the statistics. Statistics is a quantitative measure, it can tell you the properties of the distribution or data by means of quantities. So, that basic statistical constants are introduced under statistics, like measure of central tendency, measure of dispersion, like mean, median, mode under measure of central tendency, variance and standard deviation, and measure of dispersion. For basic data we discuss. Then again the same statistical constants, especially the mean and variance, of course standard deviation because it is being positive square root of variance, they are discussed for probability distribution. So, that will also be introduced before starting with random variables. So, random variables, what is random variable? Okay. Then how this particular random variable can create the probability distribution by using the probability functions, we try to understand. So, we are going to discuss some standard probability distributions. We start with discrete probability distributions. Under discrete probability distribution, we discuss about binomial and Poisson distributions. Under continuous probability distribution, we talk about exponential, uniform and the Gaussian distribution or normal distribution. So, these are the topics we are going to discuss under probability 2, my dear friends, and it is one of the important topic. See, please note that probability 2 is very high scoring topic than probability 1, but unfortunately probability 1 we can relate with the problem. So, people more likely to practice questions from probability 1. But remember one thing, probability 1, that is the basic probability questions can be asked from aptitude than in mathematics. Generally Bayes theorem questions will be asked for engineering mathematics part, whereas other basic probability questions you can expect from aptitude, my dear friends. Of course, I am going to discuss all the topics in detail in my videos, you will understand that. And if you consider the syllabus, see the topics you can understand here. For mechanical student, they mentioned in more detailed manner, like definition of probability, conditional probability, even statistical measures also mentioned clearly. Whereas for other like civil engineering, they also mentioned this mean, median, standard deviation, whereas conditional probability, they are directly starting with conditional probability. Here for EC students also mean, median, mode, standard deviation starting with statistical terms. Okay, here also you can see the statistical terms are given almost in all the branches. Hopefully I am not covering this, mean, median, mode and standard deviation, that is mentioned in all the branches equally. Then we have this conditional probability mentioned in almost all the branches, whereas for EC student they also mention like combinatorial probability, that is what you mean by basic probability, my dear friend. Basic probability, addition theorem, they all come under this particular combinatorial probability. Okay. They mention conditional probability here, and these people, see in CS they written in a reverse order actually, conditional probability and Bayes theorem written towards the end. See, that is what I am trying to say, this is an abstract syllabus, do not go with like a blueprint from this 1 mark, from this half mark, it is not like that. Okay. You may prepare for the entire syllabus, you may get a question from first topic itself, conditional probability you may get the 2 marks question, or you may prepare only first few topics, you may get question from normal distribution, or you may get question from Poisson distribution or an exponential distribution. So, do not go with like blueprint. Please remember, it is not your university examination, that is completely different, and this methodology will be completely different. This is called an abstract of the topics, not detailed topics. Even though subtopics are mentioned, this is only abstract is mentioned. Am I clear? Please remember that. Like discrete distribution, binomial, Poisson is mentioned. Here he just mentioned discrete, Poisson is mentioned. Binomial is not mentioned here for civil students. Here binomial, Poisson both are mentioned, normal is mentioned. Here normal is mentioned, here also normal is mentioned, exponential is mentioned explicitly for EC students. Am I clear? Normal, binomial, Poisson distribution, they are like normal is a continuous distribution. So, they are writing everything together. And one more interesting thing here is for EC student there is something called joint probability distribution. Generally this joint probability distributions they require for this communication system. So, generally based on the requirement either the communication faculty or we do it. I discuss this in my videos. You can find some concepts of this conditional probabilities in my videos. There is a correlation regression analysis that is only mentioned for few branches. See, generally these topics the number of questions are very rare and very few. So, generally depending on the requirement only we discuss. If at all it is needed, we will discuss in more detail, like linear regression, the regression analysis. This part linear regression is part of the regression analysis. They are not difficult, sir. They are very interesting. So, based on the requirement those videos can be created. Okay. So, that is about the syllabus of probability, my dear friends. So, the common thing you can easily understand, basic probability means we have basic combinatorial probability where we talk about permutations and combinations, using that how to find probability. Okay. Then we talk about addition theorem, conditional probability, total probability theorem, Bayes theorem. Then under probability 2 we talk about random variables, probability functions, probability mass function, probability density function, then probability distribution, discrete probability and continuous probability distribution. Under discrete probability distribution we have binomial and Poisson distribution. Under continuous probability distribution we have exponential, uniform and normal. Normal distribution is also known as Gaussian distribution. So, that is about the syllabus of probability, my dear friends. The next one is differential equation. So, differential equation we start with the basic terminology and how to find order and degree of a differential equation, that mainly needed for classification of differential equation. We also learn how to form differential equation. Then when we are learning how to solve differential equation, we start with solving first order differential equation. Under first order differential equation, the methods for solving first order differential equation, we mainly classify them into three parts. Okay. One is variable separable method or equations reducible to variable separable method. Second one is Leibniz linear form or equations reducible to Leibniz linear form. The third one is exact differential equations or equations reducible to exact differential equation. See, the second part which I was mentioning, reducible to that form. See, there may be some equations which are readily in that particular form, or you may need to reduce to that particular form. For example, the famous Bernoulli's differential equation is a non-linear, but which can be reducible to linear form by making some suitable substitution. That is the story. So, that is about first order differential equation, my dear friends. When you talk about higher order differential equation, see, if this f(x) is equal to 0, then we call it as homogeneous linear differential equation. If it is non-zero, then it is non-homogeneous linear differential equation. So, we try to find the solution of this homogeneous as well as non-homogeneous linear differential equation by writing the characteristic equation or auxiliary equation, finding the roots. Based on the roots we can write the solution for the homogeneous part, and if f(x) is non-zero, then we learn how to find the particular integral. There are some beautiful shortcut techniques for finding particular integral for functions of the form e power ax, sin ax or cos ax or x power m or e power ax into v or x into v forms. And we also have one more very interesting method called method of variation of parameters. Then we also have, like, here if you observe this k0, k1, k2, these are all generally constants. So, if they are all constant, we call it as linear differential equation with constant coefficients. If they are variables, that is called linear differential equation with variable coefficient. We also learn some special linear differential equation with variable coefficients which can be reducible to constant coefficients, and we call them as Cauchy-Euler equations and Legendre's linear differential equation, my dear friends. So, that is about differential equation. Let us see the syllabus. If you observe the first order linear and non-linear equations and higher order linear equations with constant coefficient clearly mentioned, and as I mentioned, variable coefficients which can be reducible to constant coefficient, Euler Cauchy equations. Of course, the initial and boundary value problems. See, the conditions mentioned at the same point are called initial conditions. Conditions mentioned at different points are called boundary conditions, and a differential equation problem together with initial condition is initial value problem, and together with a boundary condition is called boundary value problem. So, that is it. And you can see the same things are first order differential equations and higher order with constant coefficient, and these are the special cases, variable coefficients. That is, Euler-Cauchy equation is a variable coefficient, linear differential equation with variable coefficients, and initial and boundary value problem, same thing. I think it is copy pasted for almost all the things, and you know method for solving using variation of parameter, it is mentioned explicitly for EC students. Okay. And differential equation is not there for CS students, sir. So, for CS students only 3 topics: calculus, linear algebra, probability, no other topics for CS students. They can study multiple integrals, okay, but other topics they can skip. CS it is not there, only for these 4 branches it is there. And here also you can see the same syllabus for them also. And if you observe, the PDE part is mentioned, this is partial differential equation part is mentioned here, and Laplace transform is also mentioned here itself. Okay. Here also for them this is mentioned under partial differential equation. See, mainly even though it is mentioned, we just need to know that method of separation of variables method, sir. That is only method, and classification of second order differential equation. Mainly the classification question they can ask you, sir. That anyhow we will discuss when you talk about partial differential equations. So, this is about the syllabus of differential equations. Now, under vector calculus, we start with vector differentiation. See, in vector differentiation, we are going to mainly discuss about the 3 main operators: the gradient, del, the divergence, and the curl, okay, and the properties. So, that is all about your vector differentiation. See, the 3 vector differential operators, that is gradient, divergence, and curl, and their properties. That is vector differentiation. If you learn those properties, your vector integration will be very, very simple, sir. Under vector integration, we are going to learn the line integrals, okay, surface integrals, and volume integrals. Of course, for all these integrations, especially surface and volume integrals, the multiple integrals topic plays very, very important role. Okay. Then we have some very, very important vector integral theorems like Green's theorem, Stokes theorem, and Gauss divergence theorem. They are very, very important, my dear friends. So, that is what it is: the Green's theorem, the Stokes theorem, and Gauss divergence theorem. Okay. So, these are the very, very important theorem under vector calculus. Okay. The theorems also mentioned here. See, anyhow, I need not discuss this here. In your videos, you can find all these results and the problems. How to use these results to solve the problems, we will learn in detailed manner in your videos. And when you see the syllabus, you can see vector calculus, the gradient, divergence, and curl, and vector identities, the properties. Okay. The directional derivative is actually you can consider it as one of the properties of gradient. Okay. Here also they mention gradient, divergence, and vector identities and directional derivatives. Okay. And here vector for EC they mention little more detailed. See, sometimes as I mentioned, the syllabus may be written in different orders. One thing you need to understand is it is an abstract syllabus, not a detailed syllabus, remember that. Okay. So, here they are also talking about some very basic vector concepts. Obviously, they can study these concepts under their EM theory, my dear friends. Okay. Of course, it is like in 2 places you can repeat the same topic, divergence and curl. Okay. They are all same thing, vector identities, directional derivatives. They are not mentioned for electrical student, they are not mentioned about gradient, divergence, and curl, but without knowing how can you learn the identities, my dear friends. Some people, sir, in my syllabus they not mentioned gradient. So, without learning, go there, what happens you will understand. See, that is what I am trying to say. This is an abstract syllabus, it is not a detailed syllabus, remember. And we have line and surface integrals and volume integrals. And for civil, they not mentioned the integral theorem, but obviously volume integrals and surface integrals are there. Their application is how to convert one form of the integral to other forms. That is where the integral theorems comes into play. So, we need to understand that. Okay. So, the application of Gauss, Stokes, and Green's theorem is explicitly mentioned for mechanical students as well as other branches. See, here you see line and surface and volume integrals are given in a separate form here. Am I clear? So, that is what I am trying to mention here. Stokes theorem mentioned, Gauss theorem, and divergence theorem. Okay. Gauss divergence, Green's theorem, the 3 integral theorems. See, the syllabus is same, only thing is the way it is interpreted may be different for different branches. Okay. The next topic is complex analysis, and for civil engineering students, complex analysis is not there for GATE, but for ESC it is there. Please remember, for other branches it is there for both GATE as well as ESC. See, it is better to start with some basic properties of complex numbers before actually starting with your complex analysis, my dear friends. Then under complex analysis, that is analyzing complex functions, we need to talk about complex function, complex differentiation. So, under complex differentiation, you see this equation which I written, which are called CR equations, ux is equal to Vy and Uy is equal to minus Vx. CR equations plays very important role under complex differentiation. Okay. Then there is something called Lorentz series. See, generally in complex analysis, we follow a methodology like, first we do the preparation, then we go for actual work. Like, complex differentiation also, preparation takes more work, but actual methods for solving is very simple. Similarly, for complex integration, the Lorentz series, okay, plays very important role, because what is very important or what is required for complex integration is finding the residues at the singularities. So, for that we should know what are the singularities, what is the type of the singularity, what is the residue at the singularities. So, if you can express the function in Lorentz series, the type of singularities, okay, and the residue at the singularities can be found. That is one method. Of course, we have different methods for finding type of singularities and residue at singularities. So, that is one of the standard method for finding type of singularity and residue at the singularity, my dear friends. So, that is why we discuss this Lorentz series. So, the preparation for complex integration is how to find residue at the singularities. For that we should know what is the singularity, what is the type of singularity, what is the residue at the singularities. So, Lorentz series is one method in finding this residues at the singularities. We also have other methods, we will discuss. We have something called residue formula, we use that. Under complex integration, first we learn the basic method of doing complex integration, then we introduce what is Cauchy integral theorem, then we have residue theorem. When you have more singularities inside the contour, how to find the integral of the function, then we have some Cauchy integral formula, and we also have this real world or how to evaluate real functions using complex integration. All that we are going to discuss under complex analysis. So, if you see the syllabus for civil engineering students, it is not mentioned in the syllabus at all, whereas for mechanical students and EC electrical it is mentioned. We need to know what is analytic function. Without knowing analytic function, we cannot do what is complex differentiation, sir. Okay. So, that tells you the entire story. Analytic function, CR equations, they are very important. Here clearly mentioned CR equations is mentioned. For EC they are not mentioned CR equations, but without knowing CR equation, how can you continue further, sir? So, obviously for the later part the CR equations are needed. That is very important in identifying whether the function is analytic at a particular point or not, okay, in a particular region or not. We will use the CR equations mainly. Then we have this is complex integration, Cauchy integral theorem, the integral formula, the Taylor and Lorentz series. Okay, same thing, Taylor and Lorentz series. See, this residue theorem gives you how to find residues at the singularities at poles. Actually, finding residues at the of course, this residue formula tells you how to find residues at poles, whereas residue theorem tells you how to find the integral when we are having more singularities inside the contour. That is right. The Cauchy integral formula we have. See, the sequence and series are basis for this Lorentz series, my dear friends. Okay. Even for electrical student, you can see Cauchy integral formula, Cauchy integral theorem, Taylor series, residue theorem, and this solution of integrals I mentioned, how to evaluate some real integrals using complex integration method. We generally call it as application of complex integration. It is only mentioned for electrical student, but you can find some of these questions for other branches also. So, it is better to prepare for everything, my dear friends. Then numerical methods. See, if you actually see for many branches, I will just show you that first before actually seeing the topics. EC electrical, it is not in the syllabus, whereas civil we can find more topics like error analysis, numerical solutions to linear, we generally call it as algebraic equations, okay, and Newton's and Lagrange's polynomials, numerical differentiation and integration by trapezoidal rule, that is numerical integration it comes under, and numerical method for solving first order differential equations. This is like Newton's and Lagrange's polynomial, we call it as interpolation. So, these are the topics. You can find more number of topics for civil engineering students, whereas mechanical student we have numerical solutions to solve this algebraic equations, numerical integration and numerical methods for solving first order differential equation. So, these 3 topics I take under numerical methods 1, sir, like error and precision, that is error analysis, linear and non-linear algebraic equations, numerical integration and first order differential equation, that is method to solve first order differential equations using numerical methods. These are the topics under numerical methods part 1, whereas part 2 this is exclusively for civil students. This is exclusively for civil engineering students, like interpolation, okay. Newton's divide difference interpolation formula and Lagrange's interpolation formula we are going to discuss, numerical differentiation. Of course, this topic is not there for civil student. For some branches this particular, like I think IN or some branches they mentioned this, okay. For completeness I might have given, but for civil mechanical student it is not there in the syllabus. LU decomposition anyhow we are going to discuss under linear algebra, okay. That is the story. Then we have Laplace transform, it is not mentioned in the syllabus of civil engineering. Actually only for mechanical student it is mentioned in the syllabus of engineering mathematics, whereas for other branches it is a part of signals and systems. So, we need not study this in engineering mathematics, my dear friends, okay. Please note that. Of course, under Laplace transform we learn how to find Laplace transforms, okay, and inverse Laplace transform. Then we have some very important results like shifting theorem, multiplication division properties. We generally call it as multiplication by t and division by t properties, okay. All such properties you are going to discuss, and one more interesting thing is convolution theorem and Laplace transform of periodic function. See, mainly for mechanical student they are asking very basic questions, my dear friends. It is very simple to, even they ask the definition of Laplace transform in one of your previous GATE questions. So, do not have to worry too much about this particular topic for GATE, because for electrical and electronic students it is just a kind of review for their signals and system, whereas for mechanical student they will ask you very basic questions which can be easily handled. Civil student it is not there, not mentioned in the syllabus at all. Then we have this particular Fourier series. See, if you observe, Fourier series is mentioned in PDE for civil student, whereas for mechanical student it is mentioned in the syllabus of calculus. For EC it is not at all mentioned. So, Fourier series is to be discussed under signals and system, different subject, and Fourier series is mentioned for electrical students in calculus, okay. See, how writing Fourier series for a particular function, my dear friends, that you need to understand, nothing more than that. And half range Fourier series, if you are studying PDEs in more detail, like solving solutions of one dimensional heat equation, one dimensional wave equation or two dimensional Laplace equation, then you require this. Am I clear? That is the story. Then the final one, partial differential equation, it is mentioned as a separate chapter for civil engineering student, whereas other student it is mentioned, but as I mentioned they generally ask one question, that is classification of second order partial differential equation based on b square minus 4ac value, okay. If b square minus 4ac is less than 0, what happens? What do you call it? Okay. If it is equal to 0, if it is greater than 0, okay. So, that particular classification will be asked, nothing more than that. And then we have the method of separation of variable technique, followed by how to solve one dimensional heat equation, one dimensional wave equation and 2D Laplace equations. So, these are the topics, my dear friend. As I mentioned, for civil student it is mentioned as a separate topic, whereas for other ones like mechanical, EC and electrical student it is mentioned in as a part of calculus. And as I mentioned, the questions when you see your previous papers, hardly they are asking classification here. Even for civil students also, hardly 1 or 2 times some variant questions were asked, but mostly classification or method of separation of variables questions, which can be easily handled, and you can easily get 2 marks from this, sir. Generally people feel that this is complex topic, but it is not, it is very simple to score, okay. So, these are the topics. I compared the syllabus of your GATE engineering mathematics in various branches, so that you will understand what is the syllabus properly. And before concluding this session, I just want to give you some simple guidelines. Know the standard results and properties, my dear friends. We should definitely know. Some people say like, GATE is all about thinking and solving it. You don't have to remember anything. That is wrong, sir. We cannot do that. Okay, you own it. Okay, you don't get it by heart, sir. You own the properties so that you can use them as your own results. That is very important. And practice the results with properties. See, generally what happens when you write a result, there just practice the same result again and again. The result may be containing some function. Replace the function with different functions and practice. That is how we have to practice. You should not just like practice like same formula. Okay, like integral f dash x by fx dx is equal to log fx, like that you should not practice. You should practice with by substituting some function there. That is important. And revise result on regular basis. See, generally when I say results to be discussed or revised regularly, people feel half an hour, I don't have that much time. My dear friend, first time it may take little extra time, but if you keep on revising regularly, 2-3 minutes practice it would be. The entire integration formulas, if you practice on regular intervals, my dear friends, hardly 3-4 minutes you can practice all the results, all the standard results. Okay, you can ask like what is integral sin x. Okay, again you have some problem whether it is cos x or minus cos x, then you are out. You are out of the game. Okay, such small things. You have to know perfectly what is the result. Otherwise, you are out of the league, out of the game, remember. Okay, not only integration formulas, sir, even when you talk about differential equation, there are properties. Vector calculus, we have some properties like Green's theorem is there. You do not know how to apply that properly, then you are out. Everything, every result, standard result you should know, and you should apply with a particular example. Then you will remember it for long time. Okay, note down new problems and ideas topic wise. See, sometimes what happen while taking tests and other things, you find some new problem you might have not seen or you might have not applied that way. So, you note down whenever you find a new idea, try to incorporate that. Okay, see my dear friend, our mind is like a box. Initially it is empty, you just need to update it. Am I clear? And it is not, it is never completed, my dear friend. It is always updated. Even today I learn some new properties or new ideas. I need to be open for that, then only we can learn. Otherwise, you are out of the league. Remember, don't misunderstand the results and concept. See, I generally say, if you don't know a topic, you are safe and mathematics is safe. But if you misunderstand, you and the future generation is in the danger. Remember this. So, don't ever misunderstand the results, my dear friends. Okay. So, with this, I say thank you, my dear friends. Okay. Prepare well for your GATE and other competitive examinations. Thank you.